So your college degree is from business and physics. You only spent 3 days in a PhD program. So my guess is that, I'm pretty sure you're self-taught. You learned all these hard science engineering, computer programming, physics, and all others by yourself, engineering. How did you do that? Tell us, a student, that you can do that without going through the formal programs, basically.
Oh, sure. You can learn much faster than the formal programs.
You can learn faster than formal programs. Tell us, share some secrets with us. How
Just
can you
read
do that?
lots of books.
Huh? Read a lot of books.
Read a lot of books and talk to a lot of people.
You can become rocket scientists by reading books without...
Well, and experimenting, of course. I mean, experiments and books. You need to, because sometimes the things in the books are not correct.
Okay.
But that's basically how it works. I mean, you can learn things very quickly if you just read the books. I mean, information is all there. I mean, at the risk of sounding like a robot, your data rate in reading books is much faster than in a lecture. You can read information far faster than you can hear it. So then it's much faster to read.
Well, I'm a little bit worried we'll be out of a job now if that's the case.
So when are you going to be building a new electric airliner?
Oh man, I got a lot of fish. I got a lot of fish frying right now. I'd love to be working on electric aircraft. I think all transport, with the ironic exception of rockets, will go electric. So I think what Airbus is doing with electric aircraft is really smart, and I think they will be very happy with any investment that they make in electrification of aircraft. They will be very happy they did that down the road. But it's absolutely the right move. So I think it's very encouraging what they're doing. Hopefully Boeing and other aircraft companies start doing the same thing, because we need electrification of aircraft as well as of cars. I mean, if I wasn't super strung out, I would for sure be doing electric aircraft. Yeah.
Software engineering is probably the single biggest area that people should learn, and I think I'm always sort of a fan of physics and general economics and critical thinking. I think we really should teach critical thinking a lot more, because people, I mean, that may seem like a simple thing, but it's just like you need to just tell people, like, this is how you know whether you should believe something or not.
The fundamentals of physics that's what's most helpful. The very framework of how to think about physics is by far the most helpful, and to sort of understand how did the first scientists learn anything, and how did they change the way that they learned things? How did they change their framework of analysis over time as they learned that one mode was better than another? This is extremely helpful to know. So honestly, it's like Physics 101 is like if people really pay attention to Physics 101, that's the most valuable. And then, I thought quantum mechanics was really interesting too. It's amazing that quantum mechanics is true. It's still hard to believe, really. It's extremely counterintuitive, so that you can't just use the way that you normally would think about the way that reality works, which you can in many other areas. So because you just don't have, your intuition is not a good guide, that makes quantum mechanics quite difficult. It also combines quite a lot of advanced math and statistics at the same time. So if you're very good at statistics, then quantum mechanics would really help. Yeah.
Okay, I did statistics.
Yeah.
So
I think statistics is quite hard too.
You like statistics?
Absolutely, yeah. Statistics is very interesting. I think everyone should learn statistics too.
Everyone should learn.
Yeah, very important. Because otherwise you can get tricked too easily by these things.
I basically learn whatever I need to learn to accomplish an objective. And I think actually most people could do this, but they often self-limit. People are capable of more than they think. But I mean, what I found is if you simply read a lot of books and talk to people, you can learn almost anything. Well, this is, of course, back in the days before there were video games, and TV wasn't very good either. So, I was actually, for quite a while, the youngest and the smallest in the class. And my parents moved a lot, so I went through 6 different schools. So it was difficult to, you'd make friends, and then one year, and then you'd be in a new school the next. So books certainly were something that I found comforting, and I would read all the time, just all the time, morning to night.
And let's see, on the strong AI, man, I wish there was some solution to that. I don't know what we can do about strong AI. There are potentially some scenarios in an AI apocalypse which only affect Earth because of the optimization function of the AI. But hopefully we don't face such a situation. I think a lot of AI researchers are afraid, like, if there's a regulator that will somehow stop them from making progress. This is not true. In fact, everything where there's a danger to the public, there is regulation. So there's regulation in food and pharmaceuticals and transport, and all of these areas, there's significant progress made. So I don't think regulation of AI is going to stop progress in AI, but it may stop us from doing some foolish things in AI. And it's quite, I would say, virtually a certainty that in the long term, AI will be regulated.
I mean, I've had conversations with quite smart and well-read people who don't understand that there's like a surface carbon cycle, but if you dig stuff up from deep underground and add it to the surface carbon cycle, that fundamentally changes the chemical equilibrium of the surface of the Earth. And they're like, wow, really? Yeah, definitely. Like there's just conservation of mass is not totally obvious to people. Okay. Like you can't just create new carbon from nothing. You have to get it from somewhere.
Just disappear.
Yeah, it doesn't disappear. Yeah, exactly. So, just like basic stuff like that would be great to educate people on.
And in the case of our rocket, the propellant cost is approximately $300,000 per flight. But the rocket costs $60 million. So that's a pretty huge difference. You've got the cost of propellant essentially 0.5% of the cost of the rocket. It's comparable to that of a large jet, essentially. And so obviously, if you can achieve reusability, you can start to approach the cost per flight. The cost per flight would asymptotically approach the cost of propellant. You're factoring in maintenance and other issues. And so if something similar to aircraft occurred with rockets, then you might have the cost of maintenance of both be roughly equivalent to the cost of fuel as it is with airlines, which would mean, say a $600,000 cost per flight over time, which would therefore be a 2 order of magnitude reduction.
So this is really a good example to show that I think in terms of first principles, radically different from think using analogy, right? Using analogy, you will not find anything possible, but from the first principle.
Absolutely, and the same can be said of even building the rocket in a reusable configuration, building a rocket whether expendable or reusable, to say what should a rocket cost. One could look at what rockets have cost historically and say, well, that's what rockets will cost. Or you could say, what are the material constituents of the rocket? If you were to say, what is the weight of aluminum, titanium, Inconel, carbon fiber, and other elements, and if you had them sort of arranged in a pile in raw materials in the room and had a magic wand and could rearrange the elements into the shape that you want, then that would describe the minimum possible cost of any given physical object. And so then the trick is how you get them in the shape effectively. And if you do that, you can see that the actual cost of the raw materials in a rocket again, expendable or reusable, is quite small. It's only a few % of the price. So then the trick is, how do you rearrange those raw materials into the shape you want efficiently?
And so when the prices are wrong, then the wrong thing happens in the economy. So when you have sort of a tragedy of the commons, like the CO2 capacity of the oceans and atmosphere, and it's unpriced, or the price is much lower than it should be, then the wrong behavior happens. So effectively, we're incenting bad behavior. I mean, I just talked about how analogies are imperfect, but you know, it's kind of like if we had high taxes on fruits and vegetables and low taxes on cigarettes and alcohol. That wouldn't make sense. But that's sort of what we have right now with respect to energy, and we're very powerful forces trying to keep it that way. It's worth noting that, like, generally, when the government interferes in the economy, that usually results in a pricing error increase. But in this case, I think it's hard to miss. Like, any sort of carbon tax would reduce the effect of error in the system of prices in the economy.
There's really an amazing amount of energy that comes from the sun. It's 1 gigawatt per square kilometer, which is mind-blowingly huge. And actually, if you think about it, the Earth is almost entirely solar-powered already, in the sense that we would be a frozen ice ball at a few degrees above absolute zero, if not for the sun. The sun powers our entire system of precipitation and almost the entire ecosystem. And then there's the energy needed to power civilization, which to us seems big, but actually to the sun, it's very tiny. As I said, a gigawatt per square kilometer is a supergiant amount of energy. And at 20% efficient solar panels, that's 200 megawatts per square kilometer. I mean, what's interesting is if you look at the sort of clearance area of most nuclear power stations, you can generate more energy from solar panels than you can from that nuclear power station, which is quite amazing. All you need is 5 square kilometers to get to a gigawatt of power, which is a tiny area. Usually the clear area is much greater than that. So no problem to generate all the energy we need for electricity, for heating, for transport from solar, with some contribution from wind and geothermal and tidal. No problem at all. We just have to do it. And then we need to stop effectively subsidizing burning fossil fuels by placing,